Okay, so I'm going to start today by talking about one of the studies that we were fortunate to complete in partnership with Smithfield Foods, where we evaluated strategies with essential fatty acids to look at both sow performance, piglet growth performance, as well as piglet survivability. So to provide a little bit of background, when we think of supplemental fat sources, we typically utilize this as an energy source in the diet, but we also need to think about these essential fatty acids that also can be supplied by the fat sources. And so linoleic acid and alpha-linolenic acid are the two primary essential fatty acids we'll be discussing here. And it's important to note that certain fat sources contain higher concentrations of these EFAs. So, for example, vegetable oil sources such as corn oil or soybean oil are much higher in EFAs than animal fat sources such as choice white grease or beef tallow. And some of the recent research that's been conducted in this area stems from North Carolina State University. And they observed that sows today ultimately do not necessarily consume enough EFA, and so they're secreting more EFA than they're consuming, and this can put them in a deficient state. And when this happens, this can impair reproductive performance. And so from that, the authors suggested that sows should be consuming at least 125 grams per day of linoleic acid and at least 10 grams per day of alpha-linolenic acid. In addition to the advantages for the sow, some research that comes out of Australia suggests that providing high EFA can also reduce piglet mortalities. So with this in mind, we conducted a large-scale study with Smithfield out in Utah where we had 4 different dietary treatments and 850 to almost 875 sows assigned to each of those treatments. And so as sows were entering the farrowing room, we assigned them to one of those 4 treatments and allowed them 4 pounds per day of their treatment feed. And then after farrowing, they were allowed ad libitum access. And so to outline the 4 treatments, we had a control diet that was low in essential fatty acids provided by 0.5% of choice white grease. The second and third treatments were either soybean oil or choice white grease provided at 3% in the diet. So in the soybean oil diet, we had high EFAs, and in the choice white grease diet, we had low EFAs. And then in the fourth treatment, this was a combination fat diet where we had 3% soybean oil and an additional 2% of choice white grease in the diet. So there were some differences in feed intake throughout the lactation period, but I do want to highlight what the essential fatty acid intake was for the sows. So you'll note here that the sows that were provided either soybean oil or combinations diets provided higher lactation linoleic acid and alpha-linolenic acid intake compared to the choice white grease or the control diet. So we were able to meet our objective and ensure that sows were consuming high and low EFA throughout the lactation period. And these changes in total lactation EFA intake resulted in significant increases in both colostrum and milk linoleic acid and alpha-linolenic acid content. So these changes in colostrum and milk still occurred even though we provided diets only 4 days prior to farrowing, and then it remained throughout the rest of the lactation period. And some of these changes in colostrum and milk content may have ultimately explained some of the results that we observed in piglet weaning weights. So we saw that sows that were provided soybean oil or combination diets with high EFAs produced pigs that were significantly heavier at weaning compared to those that were provided low EFAs. And although we saw some advantages in growth performance throughout the lactation period, we did not observe any evidence for differences in survivability in the first 24 hours of life, nor did we observe differences from 24 hours throughout the weaning period. In addition to the initial farrowing performance and litter survivability characteristics, we also followed sows for subsequent reproductive performance. So we followed sows throughout a common gestation and lactation period where they were all provided the same diet. And we found that although there were some differences in EFA intake in that initial lactation period, there was no evidence for differences on the return to estrus interval, the percentage of sows bred by day 7 or day 12, farrowing rate, or subsequent litter sizes. So to provide just a little bit of some brief take-home messages from this study and then a companion paper that's published in the Swine Report this year, we know that high EFAs can certainly influence colostrum and milk EFA content. We also know from the results of these studies that EFA intake did not influence farrowing performance, piglet survivability, or subsequent reproductive performance of the sows. But we did see that sows provided high EFA produced pigs that were heavier at weaning and had greater overall litter average daily gain throughout the lactation period.